So, welcome to the deep dive. If you're listening right now, you are the learner. You're the kind of person who really craves those deep connections, those massive aha moments, but, without getting completely buried in impossible academic jargon.
Right, exactly. And today we have a stack of sources that are just, honestly, they're mind-blowing.
They really are. I mean, we are pulling from deep Earth geophysics, evolutionary biology, quantum sensing, and cognitive psychology, which sounds like a random grab bag.
Oh, it completely does on the surface. But the synthesis here is wild.
Yeah, so here is the mission for today. We are looking at a 66 million year old apocalypse, an ancient underground network that literally terraformed the planet and the actual structure of the human mind.
And the craziest part is that they are all fundamentally connected by the exact same physical and mathematical principles.
Which is just, let's unpack this. Because to understand how our modern world operates, we have to go back to the beginning.
Right, down to how we navigate without GPS, or how our brains actually perceive reality. We have to start with the most famous catastrophe in Earth's history.
The Chicxulub impact.
Exactly. We have to really look at the anatomy of that specific event.
Okay, so paint the picture for us. 66 million years ago, this asteroid hits the Earth.
Yeah, so imagine an asteroid, maybe 10 to 14 kilometers across. It slams into what is now the Yucatan Peninsula in Mexico.
And the numbers in the source material for the kinetic energy are just, I couldn't even process them.
Oh, they defy human intuition entirely. The estimate is 3 times 10 to the 23rd joules of energy.
Wait, what does that even mean in the real world?
Well, to put a metric on it, it's roughly equivalent to 100 million megaton blast.
Wow.
Yeah, or like 5 billion Hiroshima bombs detonating at the exact same millisecond.
That is just terrifying. And the sources talked about how it created this thing called a transient cavity.
Yeah.
That phrase really stuck with me.
Right, because it punched a hole roughly 28 kilometers deep into the Earth's crust. But it didn't stay that way.
Because the Earth acted almost like a liquid, right? Like dropping a pebble into a puddle.
That's a perfect way to visualize it. The rock behaved hydrodynamically. The crust got pushed down and outward, making this huge temporary bowl.
And then it rebounded.
Exactly. The mantle below bounced back up, collapsing the cavity and creating a massive multi-ring impact basin.
And today that basin is huge, right? Like 180 to 300 kilometers wide.
Yeah, but here's the fascinating geological twist. You can't actually see it. It is entirely buried under about a kilometer of younger limestone.
So if it's completely buried, how do we even know the exact shape of it?
We map it using potential field geophysics. So we look at gravity and magnetic anomalies.
Okay, but this is where the physics completely threw me. You'd think, right, if a 14-kilometer dense space rock slams into the ground and compresses everything, the gravity there would be stronger.
That's what most people assume. But the gravity signature of Chicxulub is actually a massive negative void.
A void? Why is the gravity lower where the asteroid hit?
It's all about the mass deficit. When that blast went off, it didn't just compress the rock, it shattered and pulverized it.
Oh, so it made it less dense.
Exactly. The crater floor is basically a thick lens of low-density breccia, which is just a chaotic mix of smashed rock fragments.
Like a giant bowl of rubble.
Right. You have these suevites, which are breccias with melted glass, and then huge megabreccias. And underneath, the deep rocks are highly fractured, full of microscopic empty air or water pockets.
And then all that empty space eventually filled in with light marine sediments, right?
Precisely. So imagine holding a dense bowling ball and then holding a giant porous sponge of the same size.
The sponge has way less mass.
And less mass in that specific piece of the crust means a mathematically weaker gravitational pull. You get this concentric Bouguer gravity pattern.
That is so cool. And the sources mentioned this isn't just a Mexico thing. It's like a universal barcode for craters.
Oh, absolutely. It's a global benchmark. Look at the Halford crater in Canada, for instance.
Right. It has a gravity low of about 2 milligauss.
Yeah. And just to clarify for you listening, a gal measures gravitational acceleration. The Earth's baseline is around 980,000 milligauss.
So a 2 milligauss drop is tiny to us, but huge to an instrument.
Right. It's a screaming signal that there's a 250-meter depression filled with light sediments sitting in heavy Precambrian rock.
And Westcock Lake is even wilder, right? Over a 6 milligauss anomaly.
Yes. And when you look at massive, complex structures like Manicouagan, which is 100 kilometers across, the gravity map becomes chaotic.
Because you have the light shattered rock competing with the heavy, dense basement rock that bounced up in the middle.
Exactly. It's a topographical battle of densities.
But wait, Chicxulub gets even weirder. Because the gravity in the center is a void, but the magnetic anomaly there is a massive spike.
Yeah, a huge high-amplitude magnetic anomaly right in the middle of a gravity low.
How does that even happen? How is the rubble magnetic?
It comes down to the intense heat, and specifically the suavite breccias, that rubble we talked
The
about.
smashed rocks.
Right. The crystalline class inside those suavites are highly permanently magnetized.
Like more magnetic than the solid melted rock beneath them.
Much more. Normal basement rock has a magnetic susceptibility around 400. The solid melt sheet is maybe 500, but those crystalline chunks in the rubble hit 1200.
Wow. And scientists mapped this out, right?
Yeah.
They found 5 distinct concentric rings.
Yeah, by looking at the second derivative of the magnetic anomaly, which just means tracking the rate of change, the outermost one perfectly matches that famous ring of cenotes, the sinkholes in the Yucatan.
But the whole southern half is asymmetrical, like it actively collapsed in on itself right after the hit.
It was an environment of profound structural violence, and we actually have a minute-by-minute timeline of it now.
From the ocean drilling, right?
Yeah.
Expedition 364.
Exactly. The International Ocean Discovery Program literally parked a drill ship in the Gulf and pulled rock cores from like 700 meters below the seafloor.
And I love this part, because they used paleomagnetism, which is basically like finding a compass frozen in time, right?
That's a great analogy. Because the Earth's magnetic poles flip over time, the minerals in the rock align to wherever north was when the rock cooled.
Right, so they check the solid melt rocks at the bottom, and they all point to an inclination of negative 44 degrees.
Which perfectly matches a specific geomagnetic period called Cron C29R. That is exactly when the asteroid hit.
But the rubble pile on top was super confusing for a long time.
Oh, it was a huge debate. The magnetic inclinations in the suavite rubble were just totally chaotic. Positive, negative, pointing everywhere.
And the old assumption was that the asteroid made this massive underwater hot spring, right? Like a hydrothermal system boiling for 150,000 years.
Right. The theory was that this long-term boiling slowly scrambled the magnets in the rocks. But the high-resolution paleomagnetic data proved that completely wrong.
Wait, so it wasn't the hot springs?
No. The chaotic magnetism is actually pre-depositional remnants.
Meaning they became magnetic before they even hit the ground.
Yes. These fragments locked in their magnetic fields while they were literally flying through the air or swirling in the blast, and then they landed in a totally random tilted pile.
It was literally raining highly magnetized boulders. That is insane.
It was sheer physical chaos. And it wasn't just in the Yucatan. The kinetic energy kicked off a global tsunami.
Oh man, the tsunami. The computer models for the first 10 minutes are straight out of a horror movie.
They really are. Within 10 minutes, there's a rim wave expanding out. It was 50 kilometers wide.
And 1.5 kilometers high?
Yeah, a wall of water 1,500 meters tall, moving at over 100 meters a second.
And once it hit the open ocean, it sped up to 200 meters a second.
Yeah.
It basically pressure washed the entire ocean floor of the planet.
Exactly. The bottom flow velocities exceeded 20 centimeters per second across almost all deep sea basins. It scoured everything down to the bedrock.
Which is why there are huge gaps in the fossil records on the ocean floor.
Yeah.
The dirt was just erased.
Yep, the uppermost Cretaceous sediments were completely washed away. But the crazy part is how the shape of the ocean floor actually amplified this destruction.
The hydrodynamic focusers, like the Puerto Rico Trench.
Exactly. That trench is over 8,300 meters deep, and it sits on a very complex tectonic plate boundary.
So the Caribbean plate is moving east, making this really steep underwater canyon.
Right. And when a massive tsunami hits a canyon that deep and sharp, it acts like a hydrodynamic lens. It focused and accelerated the energy.
So it made it even more destructive.
Much more. It violently scoured the trench, causing massive submarine landslides. We see the exact same violent deposition in shallower areas too, like Arroyo El Mimbral in Mexico.
The stratigraphy there is wild. It's like a 3-layer geological cake of the apocalypse.
It really is an incredible cross-section.
So at the bottom, you have these impact melt spherules, which are basically glass droplets that rain down from space.
Right, molten rock that cooled in the atmosphere.
And then sitting right on top of the glass is a layer of sand packed with terrestrial plants, like burnt pine trees.
Yeah, the backwash from the tsunami dragged entire forests from 100 kilometers inland out into the deep ocean.
And then the top layer is iridium clay from the actual asteroid. It's literally a blender full of ocean water, burnt trees, and alien space dust.
A continent-sized blender, and honestly, those hydrodynamic physics haven't changed. The Puerto Rico Trench is still a massive tsunami risk today because of that exact same underwater geography.
Wait, didn't sources say a massive tsunami hit Puerto Rico before the Spanish even got there?
Yeah, carbon dating puts a megathrust earthquake and tsunami right between 1470 and 1530 AD.
Wow.
The wave focusing is still highly active, but, a local tsunami and atmospheric dust, as horrific as they are, don't necessarily kill 75% of all life on Earth.
Right, because the impact rang the whole planet like a bell.
Yeah.
And that energy transferred straight through the Earth to the exact opposite side of the world.
This is where we see a coupled Earth systems failure. We have to look at the Deccan traps in India.
So this is a massive volcanic province, right? Like 1.5 million square kilometers of lava.
1 million cubic kilometers of flood basalt, just a continent-altering amount of magma.
And for a long time, scientists argued whether it was the asteroid or the volcanoes that killed the dinosaurs.
And high-precision geochronology basically proved that the answer is both. They happened in tandem.
But how do they actually know the exact timing? How do you date a rock from 66 million years ago with that much precision?
They use argon-argon and uranium-lead dating. So radioactive potassium-40 naturally decays into argon-40 gas at a very specific rate.
Okay.
When magma is liquid, that argon gas just bubbles away, but the second the magma cools into solid rock, it traps the newly forming argon gas inside its crystal structure.
So they can just measure the trapped gas.
Exactly. They take a tiny crystal, melt it with a laser in a vacuum, and measure the exact ratio of potassium to argon. It's an incredibly precise clock.
And those clocks showed that the main phase of the eruptions in India overlapped the exact KPG boundary.
Right, a window of about 600,000 to 800,000 years. It was a 1-2 punch.
But they weren't just coincidentally erupting at the same time. The asteroid hitting Mexico literally changed how the volcanoes in India behaved.
That is the most critical finding. There was a profound state shift in the volcanism within 50,000 years of the impact.
So before the asteroid, it was just like a steady bubbling, right?
Yeah, a continuous low-volume eruption. It caused about 3 degrees of gradual global warming. But after the impact, the magmatic system radically changed.
The frequency dropped, but the volume of each eruption doubled. How does a rock in Mexico do that to India?
It's the structural focusing of seismic waves. The impact sent a magnitude 10+ seismic pulse straight through the deep mantle and core.
And those earthquake waves converged on the exact opposite side of the planet.
The antipodal focus zone. It's like hitting a water balloon on one side and the shock waves snap together at the exact opposite pole.
And India just happened to be sitting right there.
Right. That focus shaking ruptured the existing magmatic plumbing. It caused isolated magma chambers to fracture and combine into massive megachambers.
Which took longer to fill up, but when they blew, they were twice as destructive.
Exactly. And they outgassed massive amounts of sulfur dioxide and carbon dioxide.
Which creates its insane climate whiplash. You have sulfur causing acid rain and freezing volcanic winters, and then CO2 causing long-term greenhouse warming.
The planet was oscillating violently between freezing and baking for 500,000 years.
But I have to push back on something here because it totally flips what we all learned as kids. The sources say the biosphere was already dying before the asteroid even hit.
Yes, ecosystems were already heavily pre-stressed. The data shows a concentrated volcanic pulse called the Palladampur pulse.
Right, 30,000 to 10,000 years before the impact.
Exactly. That pulse dumped massive sulfur aerosols into the atmosphere, causing a severe transient cooling event. Terrestrial temperatures dropped by 5 degrees Celsius.
So the dinosaurs were already freezing and starving before the asteroid showed up.
The biosphere was deeply traumatized, which amplified the fallout of the impact.
So just synthesize this for a second. The Earth is freezing from Indian volcanic sulfur. Then an asteroid hits, blackening the sky with soot. Acid rain is falling.
Primary photosynthetic productivity basically collapsed globally.
The planet became a dark, cold, rotting graveyard. But strangely enough, that is the perfect recipe for one specific type of organism to thrive.
Right. The physical devastation created an unprecedented planetary scale pool of dead, decaying organic matter.
Which is an all-you-can-eat buffet for fungi.
Precisely. Saprotrophic organisms, fungi that eat dead matter, absolutely exploded. We call it the global KPG fungal spike.
But how do we even know that? You can't exactly dig up a fossilized mushroom from 66 million years ago.
No, but you can find their microscopic microscopic spores,
Yeah.
researchers did highly precise panological analyses on sedimentary boundary cores.
Like the ones from the Barring Pit in Colorado and mud buttes in North Dakota.
Right, and they matched findings from New Zealand, too. It was a global fungal bloom.
But there's a massive hurdle they had to overcome to even see the spores, right?
Yes, the preparation technique. Normally, scientists use harsh hydrofluoric acid to isolate tough plant pollen from rock.
But that acid completely dissolves delicate fungal spores.
Exactly. So they had to use a specialized, non-acidic microfossil prep. When they washed the rocks gently, they found this massive spike in fungal abundance lying right on top of the boundary clay.
And there's chemical proofs too, right? Alpha AIB?
Yeah, alpha-aminosobutyric acid. It's a non-proteinaceous amino acid, basically a secondary metabolite produced by soil fungi.
So finding tons of alpha AIB in the dirt is basically a chemical smoking gun for a huge fungal bloom.
Absolutely, an irrefutable molecular signature. But the craziest part of the timeline is that the fungal spike started before the asteroid hit.
Right, matching exactly with that Paladpur volcanic freezing event we just talked about.
Exactly 30,000 to 10,000 years prior. The cold disrupted the forest so badly that it fueled an early fungal expansion.
And that sheer mass of fungi exerted this massive evolutionary pressure on everything still alive.
Yeah.
Which leads to the FIMS hypothesis, right?
The fungal infection mammalian selection hypothesis. It views the fungal bloom as a biological evolutionary filter.
Because fungi love cold temperatures, and they struggle to infect things with high body heat.
Exactly. So in a dark, freezing impact winter, cold-blooded reptiles, the non-avian dinosaurs, couldn't regulate their internal heat.
So they were basically walking incubators for fungal spores.
They were highly susceptible to systemic lethal mycosis. They succumbed to the pathogens.
But the mammals survived because we were endothermic. We were walking space heaters.
Our elevated internal temperatures, around 37 degrees Celsius, acted as a natural thermal shield.
We literally burned off the infection. That is such a wild evolutionary bottleneck.
And because they survived that specific filter, early mammals could expand into all those empty ecological niches, which eventually led to us.
It's an incredible story. But framing fungi as just the scavengers of the apocalypse is actually really unfair to them.
It's a massive disservice. If you go back hundreds of millions of years, fungi are the original ecosystem engineers.
The reason life even exists on land.
Yes, they colonized land at least 800 million years ago, maybe even up to 1.4 billion years ago.
Wait, that's way before plants or animals.
300 million years before multicellular land plants. They were terraforming the barren rock.
But how do you date something that old if they don't leave bones? The sources talked about horizontal gene transfer.
It's a brilliant molecular technique. Horizontal gene transfer is when species non-sexually swap genetic code.
Like just bumping into someone and suddenly acquiring their blue eyes.
Exactly like that in the microbial world. But for a transfer to happen, both organisms have to be in the exact same environment at the exact same time.
Ah, so if an ancient fungus has a gene from an ancient algae, you know they hung out together.
Right. These transfers act as relative chronological markers. They prove terrestrial fungi were interacting with the single-celled ancestors of plants way before forests existed.
So what were these fungi doing on the rocks for millions of years?
They were infiltrating the mineral substrates. Their hyphae secreted powerful organic acids to break down silicate rocks.
Literally dissolving solid rock.
Yeah, to release locked-up nutrients, they bound loose sediment together and basically built the planet's first organic-rich soils.
And we have fossils of this, right? Tortatubus.
Yes, from the early Silurian, about 440 million years ago. It's the oldest fossil of any land-dwelling organism.
So the fungi build the soil, and then the first primitive rootless plants try to come onto land, but they don't have roots to get nutrients.
Which is where a massive scientific assumption just got completely overturned.
Because all the textbooks said the plants partnered with glomeromycota fungi.
Right. For decades, that specific phylum was considered the mother of all plant-root symbiosis.
But they had the wrong partner.
Entirely wrong. Recent molecular studies of basal liverworts like Haplometriopsida show they actually partnered with a primitive fungus called Mocoromycotina.
And this wasn't just a casual partnership. The fungus physically goes inside the plant's cells, right?
Yes, intracellular colonization. Under electron microscopes, you can see these incredibly fine fungal coils, just 0.8 to 1.5 micrometers across, sitting inside the plant tissue.
Creating this perfect metabolic loop. The plants trade the sugars they make from sunlight, And in return, these microscopic fungal coils act as their roots, scavenging phosphorus and water from the dirt.
It enabled the initial establishment of land plants.
I just love this analogy. Plants didn't really conquer the land. They basically hired a subterranean fungal construction crew to build the infrastructure for them.
Infrastructure is truly the best word for it, because mycelial networks exhibit incredibly sophisticated, mathematically optimized topology.
Yeah, researchers modeled this using graph theory, and they found these networks are small world and scale-free.
Right. They have to balance exploring a patchy environment for resources while maintaining efficient internal transport and fault tolerance.
So they build dense clusters locally to search, but then they build these long, thick transport cords and anastomoses to act as superhighways.
And different species use different math. Phanericate velutina optimizes for speed and rapid reconfiguration. Water moves through it at like 148 centimeters an hour.
But then Phallus sympeuticus is the exact opposite.
Yeah. It uses extreme redundancy, high connection costs, but highly stable cords using stigmergic structural preservation.
Meaning it builds heavily reinforced paths based on historical usage and builds to last.
Exactly. But the fluid dynamics inside these tubes is where the physics gets truly elegant. It's modeled as laminar Poiseuille flow.
And the golden rule there is that resistance is inversely proportional to the fourth power of the radius.
Which is an immensely powerful scaling law.
Okay, let me try to translate this fourth power math.
Yeah.
If you double the width of a fungal tube, it doesn't just carry twice the fluid. 2 to the fourth power is 16.
Right, it carries 16 times the fluid capacity.
That's like a city instantly upgrading a dirt road into a 16-lane superhighway the second it finds food. And then, using negative feedback, it deletes the roads going nowhere.
It's decentralized biological swarm intelligence, and it's not a passive flow either. They tracked it using radioactive isotopes like carbon-14 alpha AIB.
Wait, they gave the fungi radioactive chemicals?
Yeah, to watch how things moved, and they saw the transport is pulsatile. It moves via network-wide coordinated pressure waves.
It's literally biological computer routing, which is why computer scientists are actually copying it, right? The mycelium protocol.
Yes, they took that exact decentralized, self-healing mathematical logic to build fault-tolerant computer databases.
We are mapping underground mushrooms to build the internet. But it gets even crazier. Aerospace engineers are using the exact same concept, navigating by an underground map to fix GPS.
It's a striking parallel. They are developing magnetic anomaly navigation, or MagNav.
Which is completely passive and GPS independent. So it's totally immune to electronic jamming or spoofing.
Exactly. In a world where satellite signals can be blocked, MagNav is a mathematical failsafe.
But wait, how is this different from a normal compass? A compass uses the Earth's magnetic field.
A compass relies on the main geomagnetic field, which is generated by the liquid iron in the Earth's outer core, and that is highly dynamic.
Right, the magnetic North Pole is constantly wandering.
Yeah, it moves kilometers a year. But the crustal magnetic anomaly field is exceptionally stable.
Because it's made of permanent rocks, like the iron deposits or those massive impact melts at Chicxulub we talked about.
Exactly. Ancient volcanic basalts, tectonic boundaries, they form a permanent, stable magnetic fingerprint etched into the Earth.
So how does an airplane read a microscopic magnetic barcode on the ground while flying hundreds of miles an hour?
It takes a huge leap in quantum physics. They use nitrogen vacancy, or NV diamond sensors.
Okay, NV diamonds. What exactly is the vacancy part?
So in a perfect synthetic diamond, you have a grid of carbon atoms. In an NV center, they swap one carbon for nitrogen and leave the space next to it totally empty.
A tiny atomic pocket.
Right, and electrons get trapped in that pocket. When you shine a green laser into it, those trapped electrons absorb the energy and emit red light.
And the red light changes based on the magnetic field below the plane.
Exactly. The intensity changes based on how the external magnetic field interacts with the quantum spin of those electrons.
That is so sci-fi.
It is. And because it relies on fundamental quantum states, it doesn't suffer from mechanical drift like older sensors. Plus, it's a vector sensor.
Meaning it measures the magnitude in the 3D direction, not just the total strength.
Which gives you precise position and heading data.
Okay, but here's my pragmatic question. If the ground is a giant permanent barcode and we have quantum sensors to read it, why did we ever spend billions on fragile GPS satellites in the first place?
Because of platform noise. That was the massive technical hurdle.
Platform noise.
If you put a hypersensitive quantum magnetometer inside a modern aircraft, it's instantly overwhelmed.
But because the plane is made of metal and wires.
Right. You have spinning turbines, high current electrical wiring, massive avionics. The plane is basically a loud, screaming electromagnet.
Drowning out the tiny magnetic whisper from the rocks below.
Exactly. And the math required to filter out that noise in real time just didn't exist in a portable format until recently.
So how do they filter out the plane's screaming noise?
Using advanced aeromagnetic compensation models. First, they simulate the aircraft's induced and permanent magnetic fields to build a digital clone of the plane's noise.
And then just mathematically subtract it from the real data.
Yes, and they combine that with extended Kalman filters, or EKF, which continuously update the parameters mid-flight.
The sources mentioned covariance adaptive filtering, which I thought was so smart. It dynamically adjusts the filter based on how much noise is happening that exact millisecond.
Exactly. If the radar spikes, the filter adapts, and you don't lose navigation. And a lot of this math is actually open source now, like the magnav.jl package in Julia.
But solving the noise is only half the problem, right? You still need a perfect map of the crust to compare the data against.
And making that map is incredibly difficult. You have to compile decades of historical marine and aeromagnetic surveys.
Like the magnetic anomaly map of North America.
Right, built by the USGS, the Geological Survey of Canada and Mexico. They stitched thousands of regional surveys into a 1-kilometer resolution grid.
But stitching them together introduces massive errors, right? Because a map from 1970 doesn't perfectly line up with a map from 1995.
We call those datum shifts. Different calibrations and survey heights create these spurious long wavelength errors on the map.
Artificial anomalies that look real but aren't, like a 150-kilometer error.
Which would easily crash an autonomous plane. So to flatten those out, geophysicists use high-altitude satellite data, like from CHAMP.
Because the satellite is so high, it sees the pure, broad magnetic field without the local surface noise.
Exactly. They joint invert that satellite data with the messy local maps and apply a 500-kilometer high-pass filter.
Which smooths out the seams and gives you a perfect, stable map.
Yes, essential for precision magnav.
I really want to hone in on this idea of filtering out noise, because extracting a true signal from a sea of overlapping, chaotic data isn't just an engineering problem.
No, it's actually the single greatest flaw in the human brain.
Which brings us to the cognitive psychology part of the dive. We are fundamentally wired to see patterns that aren't there.
It's an evolutionary survival trait. The brain is a pattern-seeking machine optimized by risk asymmetry.
The difference between a type I and type 2 error.
Exactly. In the ancient jungle, a type 2 error, a false negative, means you look at a bush, you miss the hidden tiger, and you die.
Game over.
But a type I error, a false positive, means you mistake a shadow for a tiger and you run away. It costs some energy, but you live.
So our brains evolved to be hyper-paranoid. We naturally produce false positives.
And this cognitive phenomenon is called apophenia.
Coined by Klaus Conrad back in 1958, right?
Yes, during his studies on schizophrenia. He defined it as the unmotivated seeing of connections in completely random data, accompanied by a feeling of abnormal meaningfulness.
In everyday life, we all have it. Pareidolia, like seeing faces in the clouds or the man in the moon.
Or seeing a pattern at a roulette table. It relies on template and prototype matching in our long-term memory.
Because our brains just quickly force messy data to fit a pre-existing template, prioritizing speed over accuracy.
And once it locks in, confirmation bias takes over, ignoring any contradictory evidence.
The ultimate case study in the sources was the Bermuda Triangle.
Oh, a classic example of apophenic construction.
Because everyone already has this pop culture template that the Bermuda Triangle is mysterious. And then in 2016, this viral documentary claimed they found the solution using satellite imagery.
Right, they saw these hexagonal-shaped cloud patterns.
Honeycomb clouds. And they loudly claimed they were massive microbursts sinking ships with 160-kilometer winds.
But meteorologists instantly debunked it. Those are just open and closed cell convection patterns.
Which happened everywhere. Cold air meets warm water.
Yes. There is mathematically zero anomalous concentration of shipwrecks in the triangle compared to anywhere else. The mystery simply doesn't exist.
But here's the core philosophical danger. From a first-person perspective, apophenia feels completely indistinguishable from genuine scientific insight.
The dopamine rush is identical. The aha moment of a false pattern feels just as real as a true discovery.
Which is terrifying for modern professions.
Yeah.
Like a financial trader looking at random, noisy stock data, swearing they see a pattern and betting millions of dollars on it.
They aren't lying to themselves. Their brains are simulating the feeling of discovery.
But they're basically just looking at hexagonal clouds over the Bermuda Triangle.
Which is why we have to rely on rigid mathematical modeling and statistics to decouple ourselves from our own flawed intuition.
Which perfectly ties this entire deep dive together. We are biological machines, highly prone to seeing ghosts in the noise. Objective math is our only lifeline.
It absolutely is.
Let's just step back and synthesize this. The physical trauma of Chicxulub didn't just end an era. It resonated through the planet, rupturing volcanoes in India.
Triggering a catastrophic climate whiplash that poisoned the biosphere.
And that chaos activated a deep-time fungal network that had been terraforming the crust for 800 million years.
That fungal explosion acted as a thermal filter, handing the planet over to the warm-blooded mammals.
Us. And now we use quantum math to navigate by the magnetic scars of those ancient rocks, and we model fungal networks to build the internet.
All while relying on algorithms to filter our data because our ancient mammalian brains are wired to hallucinate patterns to keep us alive.
The geophysical, biological, and cognitive processes are just profoundly intertwined. It's unbelievable.
It really changes how you view the world.
It does. And it brings us to a final lingering question for you, the learner. If the feeling of a genuine aha discovery is biologically identical to apophenia, a false positive designed just to keep her ancestors alive, then what deeply held conviction do you have right now about how your life or the world works that is actually just a hexagonal cloud over the Bermuda Triangle? Think about that. Thank you so much for joining us on this deep dive. See you next time.